Hello, in this video I'm going to explain how you can calculate the escape velocity from the surface of the Earth. Say I have a stone of mass m lying on the surface of the Earth. At what speed must I throw this stone at such that it can totally escape from the gravitational field of the Earth? Now obviously the stone is going to slow down as it tries to escape from the Earth. But it will be a mistake to try to solve the problem using an equation of motion. The reason is because the gravitational force follows the inverse square law. So as the stone tries to escape, the gravitational pull is going to decrease. So it's not a constant force, so it's not a constant deceleration, and therefore you cannot use the equation of motion because the acceleration is not constant. The way to solve this problem is to use the principle of conservation of energy. So as the stone tries to get away from the Earth, it must gain GPE, and therefore it must be losing KE. If you add up the GPE and KE at any position, it should be a constant. So if we take the initial position of the mass to be on the surface of the Earth, and the final position to be a point so far away, the so-called the point at infinity, then we can write that the initial GP and KE is equals to the final GP and KE. The initial GPE, when the mass is on the surface of the Earth, can be written as negative gmm over r, where big R is the radius of the Earth. Its initial KE is of course half mu squared. The final GPE, which is the GP of the mass when it's at a point at infinity, is of course 0. For the final KE, we are going to write it as 0. We write it as 0 because we are trying to solve for the minimum launch speed u such that the mass can escape. If we had written KE as some other positive number, then you would have gotten a value of u that's larger, of course, and that wouldn't be the minimum. Rearrange the equation and you get u is equals to square root of 2gm over r. Sub in the numbers. So the gravitational constant, the mass of the Earth, the radius of the Earth, and you get this number 11.2 kilometers per second. Now realize that the mass of the object doesn't matter. So this is the escape velocity for any object from the surface of the Earth. So go ahead, if you can jump off the floor at 11.2 kilometers per second, you'll be not landing back to Earth anymore. Ta-ta!